All right, good folks. Today is Friday the 20th. We're gonna do the warm up. I didn't put that on there yesterday, but we are doing a note card. Thank you. Okay. Our note card today is going to be on writing linear equations. There are 3 steps that we need to remember, and then we'll go more in detail next week with the note cards on writing equations. That's going to be super important. The only thing you need to squeeze in, because we wrote this part yesterday, is that we're going to do the note cards after the warm-up. Let's turn and look at the warm-up, please. I told you I wanted to do those 2 warm-up questions because they were pretty good. All right, we need some space at the bottom here. Move my little cursor so you can see a little bit better. And I still see some kind of a lot of fidgeting and moving, so I'm going to wait till we get a little bit settled. Let me pause real quickly so that we can get this out. All right, so warm up. All right, here when you're solving, please watch what I'm doing because you're gonna see a problem like this again, okay? All right, so very first thing that I need to do is distributive properties. So we're gonna perform distributive properties. You're gonna multiply this fraction to both numbers in the parentheses there. You're gonna multiply this fraction to both numbers in the parentheses there. So let's do the first. Please watch. Okay? You're going to do, Zoe, you good? You okay? So 2 over 3 times 3x. Let's do that first. Let's write this here. 2 over 3 times 3x. Okay? Write this down. Oh, you gotta write this stuff down. Dylan, y'all writing? All right. This is a whole number. To make a whole number to a fraction, put a 1 under it. Now we're going to multiply straight across. So we have 2 times 3, that's 6. So we're going to have 6x on the top. And 3 times 1 is 3. Come on, what are you looking for, friend? You want to just keep this and use it. Okay, come on. Because you're wasting too much time. 6 divided by 3 is going to give me 2. So this is going to be 2x. So when you multiply this, you're going to get 2x here. Okay. We're going to do the same thing for the second number. We have 2 over 3 times 6. Again, we're going to write the whole number 6 into a fraction by putting a 1 under it. Now we're going to multiply straight across. We have 2 times 6. That gives us 12 on the top. 3 times 1. That gives us 3 on the bottom. Some people reduce diagonally, so they don't have to reduce in the end. But if you don't know how to do all of that, just multiply straight across. 12 divided by 3 gives you 4. So this is going to be plus 4 here. Bring down the equal sign. Now you're going to multiply half times both numbers in the parentheses. That's distributive property. What is half of 4x? 2x. What is half of a negative 12? Negative 6. Any questions so far about distributive properties? The next step is to move the variables to the same side. Doesn't matter which one you move, they're both the same. So you're going to subtract 2x over here to move it here. And I'm subtracting because 2x is a positive. So to move the whole thing, you add or subtract. When I subtract 2x on this side, 0, and I'm left with the positive 4. When I subtract 2x on this side, it's 0, and I'm left with the minus or negative 6. The variables cancel out. Is this true? Is 4 equal to negative 6? Is 4 equal to negative 6? No, this is false. Since your answer is false, this has no solution. If the answer was true, it'd be infinitely many solutions. So anytime the variables cancel out, you're going to have either 2 things. It's either going to be no solution or infinitely many. If it's true, it's going to be infinitely many. If it's false, it's going to be no solution. I'll pause to give you a chance to write. Any questions? Okay. All right, let's do the next one. It says, how many times larger? Doesn't say how much, many more times or difference between. Times is multiplication. So to figure out how much was multiplied to get the other number, you have to do the opposite, which is division. You want to know how much larger this is. This is the larger one from this one. So this one's going to go on top. How, Ms. Reyes, do you know that this number is the largest? It's because the exponent is larger. This is a positive 7. This is a positive 5. So that means this number is going to be bigger than the other. So we got this number divided by the smaller one. Any questions? And it's not small just because this 3 is small. It's small because the exponent is smaller. Look at the exponent when you're comparing which one is bigger and which one is smaller. The exponent is bigger. That means that number is going to be bigger if you were to write it in standard form. If the exponent is smaller, that means that number is going to be smaller if you were to write it in standard form. Okay? So now let's divide. Let's divide the numbers together, and then let's divide the exponents. Let's do the numbers first. What's 9 divided by 3? 3. So far we have 3 here. Okay. Now let's do the exponents. The bases on these exponents are the same. So remember, what do you do with the exponents if the bases are the same? Somebody said it. Not add, that's multiplying. So you subtract. So you got 10 as the base, and you're going to say what minus what? 7 minus 5. What's 7 minus 5? 2. So it's 10 to the second. So this is going to be 3.0 or 3 times 10 to the second. If you don't see the decimal, it's automatically behind the last number. So it is in the right place, okay? So that's okay to write it as 3 times 10 to the second. Any questions? All right, so let's look at the note card. The first one is your area formulas. Okay, area of a square, s to the second power. Rectangle, length times width. Circle, pi r squared. Parallelogram, base times height. Triangle, 1/2 base times height. Trapezoid, 1/2 height, b1 plus b2. That's your first note card. Second note card are your volume formulas. Okay, that's volume. We got volume of a cube, s to the third power. Bless you, baby. S to the third power. Rectangular prism, length times width times height. Cylinder, pi r squared times height. Cone, 1/3 pi r squared times height. And sphere, 4/3 pi r to the third power. Those are your volume formulas. Please make sure you keep reviewing those, okay? Pythagorean Theorem, you only use with a right triangle. It's a squared plus b squared equals c squared, where your a and your b are the sides that actually form that right angle. The side opposite of the right angle is the hypotenuse. That's your c. Your fourth part is slope, or rate of change. You use the same formula, okay? For rate of change in slope, you're either going to use m is equal to rise over run, or m is equal to y2 minus y1 over x2 minus x1. When do you use rise over run? For pictures. For a line, because you pick 2 points on the line and count your rise over run. Or a picture, it may give you a ramp and it asks you for the slope. If it asks you for the slope of the ramp, use rise over run. If it asks you for the length of the slanted side, you use Pythagorean Theorem. Read to figure it out. Oh, and when you use the other formula, this formula right here, you use it when you're given 2 points or you're given a whole bunch of points. And all you do is pick 2 points from the table. Fifth card is slope-intercept form. That's y equals mx plus b, where your m is the number that's attached to x, your b is your starting amount, or where the line crosses the y-axis. There are 4 kinds of slope, 4 kinds. You have a positive slope, that's when your line goes up. That means m is going to be a positive number. Use rise over run. You have a negative slope, that's when from left to right, the line is going down. That means m is a negative number. You have 0 slope, that means you have a flat line. It's laying flat. Horizontal lines are flat lines. They have zero slope. The answer to M is 0. Or you have vertical lines straight up and down. You cannot walk up a straight up and down like a wall. You can't walk this wall. You can climb it, but you couldn't walk it. That has undefined slope. Card 7, multiply exponents with like bases. These you can only do this when the bases are alike. Add the exponents. So when you multiply exponents that have the same base, all you're doing is adding it. This is saying 3 is being multiplied 5 times and 3 is being multiplied 2 times. So 3 is being multiplied a total of 7 times. Dividing exponents with like bases. This is card 8. You subtract the exponents, okay? You subtract the exponents. Power of a power. That means an exponent raised to another exponent. You multiply those exponents together. So when you see a problem looks like this, multiply the exponents. The card for today, card 10, you can have that card out. It's writing linear equations in slope-intercept form, and I'm going to pause to give you a chance to write. This is card number 10. Okay. Yes, sir.
Who sits here like in first period? Who sits here like in first period?
Jalen? Yes, love him. All right, steps. First one, number 1, you find the slope, M, okay? There are 2 formulas for slope. Right? Rise over run, or y2 minus y1 over x2 minus x1. If they don't give it to you, sometimes they'll give you the slope. Then all you do is just plug the slope in. But if they don't give you the slope, then you got to find it. And these are the 2 formulas that you use to find slope. That's the very first step, find slope. Dylan, you got that? Did you write it, babe? Second step. Second step is to find the y-intercept. The letter for y-intercept is B. Okay? In order to find B, you use the slope-intercept form, y equals mx plus b. You use this. You're going to use the m that they gave you, plug that in, and they had to have given you at least 1 point. So you plug in the y coordinate here and the x coordinate here. And then solve for B. And we've done that before. I'm going to show you again how to do that next week, in case you forgot. Okay? The last step is to substitute. You already found M, you already found B, so now all you do is just plug in the M and plug in the B, or substitute the M and the B into the slope-intercept form, and there you have an equation. Y is equal to whatever the number for M is, X, plus or minus whatever the number is for B. If B is a negative number, you're going to say minus whatever that number is. If B is a positive number, you're going to say plus whatever that number is. Okay? If B is negative 7, you're going to say minus 7. If B is positive 4, you're going to say plus 4. Questions, comments, or concerns? All right, I'm going to stop the video here. After you finish your card, I need you to go ahead, take your quiz, and submit your work. That's what we're going to do when we come back from lunch, okay?
I was going to say it's 10:47.
I got this. Do this every day.